The vapor pressure of water at 20 degrees centigrade or Celsius is 17.5 millimeter mercury. If 18 gram glucose is added to 178.2 gram water at same temperature, what is the resulting vapor pressure of this solution? This resulting solution, so we'll find out. So again we use the relating lowering vapor pressure, that is P naught of pure vapor pressure minus P naught of S, and regarding P naught of A. So if you are taking P naught of A, so we can take a mole fraction of that is glucose, okay, divide by mole fraction of glucose, moles of glucose, and divided moles of the, we can say, water. So your mole fraction of solution is 17.5 millimeters given, and divide by, we don't know the P naught of S, and this is 17.5, and mole fraction of glucose is, it is given 18 divided by 180, and this will be also 18 divided by 180, and plus for water is given. So how much water is given? So it is 178.2 gram. So 172 gram and divided by molar mass of water. So if you solve it, so on solving, so whatever pressure of this solution will be, this will be 17.325 millimeter of mercury. So we can find what is the answer. So if you see carefully, it is coming C answer is coming, is correct answer. A relative decrease in vapor pressure of an aqueous solution NaCl is 0.167. So NaCl is your electrolyte, and number moles of NaCl present in 180 gram of water is how much? So relating lowering of vapor pressure is delta P by we can see P of this vapor pressure of the pure solution, and divide by, that is given here 0.167. this is already given here, that is decrease in vapor pressure. This is called decrease in vapor pressure. And now this is equal to moles of solute divided by the moles of the solution. So moles of solute how much? So moles of solute is NaCl. So NaCl is electrolyte, so we take 2 is NaCl I value, and moles we don't know, so N we don't know how much moles is there. So 2 into N, and this is 2 into N. For water is 180 divided by 18. So what is the value of N? So if you solve here, N is equal to 1 mole. So answer is our B. In the following solution, 1 molar is sucrose, 1 molar is potassium ferrieyanide, and 1 molar is potassium sulphate. What is the maximum value of vapor pressure of the solution B? So when the vapor pressure of solution maximum, so in that case I value should be very less. So what is the I value for sucrose? So for P case I value is, so we can say 1. For Q I will be potassium ferricyanide. So potassium is K3Fe CN whole 6. So Fe is plus 3 charge, 6 minus 3. So it's ferricyanide. So you can see 3 plus 1. So I value is 4. And in case of C, what is the I value? I is potassium sulphate. So K2SO4 is again 3. So only minimum is sucrose. Okay. So answer will be your A. A is our correct answer. The vapor pressure of a pure benzene is 268 torr, and how many moles of non-volatile solute per mole of benzene is required to prepare a solution of benzene having vapor pressure 167 torr at same temperature, that is 50 degrees centigrade. So we can use pure vapor pressure, that is P naught, and solubility, and divide by PS. So if you use PS, then we can use moles of the solid divided by the moles of the solvent. That is given here how much? So it is given here. So if you solve it, solute, this is your solvent. So P naught pressure will be how much? So it will be, so this is given here 268 is the vapor pressure minus 167, and divide by 167, and moles of non-volatile solid is N, and for benzene is per mole, that is 1. So if you solve it, so N will be equal to how much? It is 0.605. This means B is our answer. If a relative decrease in vapor pressure is 0.4, so delta P by P is given here for a solid containing 1 mole of NaCl in 3 moles of water. So what is NaCl is percentage ionized. So already relating lowering body pressure, that is delta P by P is given 0.4, and moles of solute is definitely 2 into 1 mole, okay, right? But how much it is ionized? So 1 mole ionized, we can write here, this will be you can say I, And I said we don't know, we need to find out, so we can write it I into 1 and plus 3 moles of water. Now if you solve it here, I will equal to you will get here 2. Now what is I? So if you take NaCl, it will split into Na plus and Cl minus, so this will be alpha alpha, this will be your 1 minus alpha. So it is actually I is equal to 1 plus alpha, that is 2. So alpha equal to your 1, that means it is what is associated. So alpha, whenever you are taking 1, so this is your 100% dissociated. So answer will be your it is 100%. So the NaCl is 100% ionized in this question. Vapor pressure of CCl4 is 143 mm mercury, and weight of non-volatile solute is given 0.5 gram, and this is dissolved in 100 ml of CCl. Density also given 1.538. What is the vapor pressure of solution? So we have to find the solution. So we can take this pure vapor pressure minus vapor pressure of solute divided by P naught A. So if we take P naught A, so it will be mass of solute divided by the mass of the solution. So mass of solute is given, that is 0.5 gram of non-volatile solids, and molar mass is 65, and divided by 0.5 by 65 plus. Now this is your 100 CCl4 is 100 and density is 1.538, and molar mass of CCl4, if you solve it, it is your 154 gram. Now what is the pure vapor pressure? It is given 143. So we can say 143 minus P naught S by 143. So this is equal to this whole value. So if you solve it, this whole values, you will get pressure of solute will be, for solute, this will be equal to 141.9 millimeter of mercury. You can solve it, you will get this answer exactly. So our answer is A is correct answer. This one is correct answer. The vapor pressure of water at 20 degrees centigrade is this much, given 17.54 millimeter of mercury. What will be the vapor pressure of water in the apparatus shown above, down here? So when the piston, this is the piston, and this is the water vapor, and this is the liquid water. The whole is our liquid water. You can say this is our liquid water is given. All water is liquid water, this one. Now when the piston is lower, so when you are decreasing piston downward direction, when you are decreasing piston downward, so decreasing volume of the gas above the liquid, so this volume is decreased to 1/2 of the initial volume. So if initial volume is V, if Vi is the initial volume, and if you are making the half of coming this side, at that time what is the vapor pressure? Now you have to keep remember, if you decrease the volume of this whole by this lowering the piston, so vapor, there is no effect on the vapor pressure, because this will always try to maintain. Vapor pressure does not depend upon the volume which is occupied. Vapor pressure of any substance, it will depend upon the solvent. It depends upon the nature of solvent and temperature. It's not depending upon the volume or surface area. So it never depends. This means if you decrease the volume, half volume, 1/4 volume, 1/3 volume, the vapor pressure in this liquid will be remain same, that is 17.54 millimeter of mercury. So you have to keep remember, this is one of the important points. Vapor pressure of any gas does not depend upon the surface area, volume of the gas which is above the liquid, right? It will always remain same. Okay, so that is 17.54. So answer B is correct answer. Which combination of 1, 2 and 3? So 1 is your vapor pressure, second is intermolecular forces, and third is the latent heat of vaporization is correctly matched. Now you have to keep remember, if the vapor pressure, okay, if vapor pressure is, suppose if vapor pressure is very low, okay, then why it is low? Then in that case intermolecular force will be definitely it will be very high, and if intermolecular force is very high, second is our delta heat of vaporization will be also very low, means you will get a less amount of heat, right? So if vapor pressure is very low, molecular force is very high of the solvent, and heat of vaporization will be very low, right? So we can find, so first is the vapor pressure. If vapor pressure is very high, so intermolecular force will be weak, so this is correct, but heat of pressure will be large, so A is not possible. high, strong, this is obviously not possible. If it is low, then intermolecular force must be strong. C is rejected. So now first is, if vapor pressure is low, so definitely intermolecular force is strong and heat of vaporization is small. So our answer D is absolutely correct answer. The vapor pressure of benzene is 53.3 kilopascal, this temperature, but it falls to this pressure when you dissolve 19 gram of non-volatile organic compound in 500 gram of benzene. So this is the solvent. What is the molar mass of this solid compound? So we can use, so pure vapor pressure is 53.3 and it is falling to 51.5 kilograms. So we can write it 51.5, and if you divide by 51.5, so we can directly write, and weight is given 19 and molar mass, that is we don't know, and benzene is 500 divided by benzene molecular weight is your 78. Now if you solve it the whole equation, so you will get molecular mass will be this one. How much? That is 84.8, it is almost 85. So out of this, which option is correct? So B option is correct here, that is 85. You can see here B is correct option. Okay, this is correct option. Which of the following would lead to an increase in the vapor pressure of a liquid? Either increasing temperature when you are adding the non-volatile solute. So definitely if you add non-volatile solute in any solvent which is volatile, so vapor pressure will decrease. Yes, if you increase the temperature, vapor pressure will increase. So adding a non-volatile solute, it will decrease, not increase. So definitely Q is our wrong option, A is our correct option. So vapor pressure depends upon the temperature. Vapor pressure depends upon the your rate of evaporation. Vapor pressure depends upon the non-volatile solids when you are not adding. When you add, it will decrease. So if it is pure liquid, so it will increase by temperature. So answer is only A is correct answer. Q is not possible. Both this is correct. This is obviously answer. B, C, D is incorrect answer. A is correct answer. B is correct answer of this question. 4 containers are taken at the same temperature. So you can see A, B, C, there are 4 containers and temperature is same. But concentration of A and B is same. So you can see concentration of A, this is a urea solution. It is given W by del percent. A and B is same, but C and D. So actually this should be C, should be B. The diagram is wrong, and this should be C and this should be D is correct. So let us take whatever the diagram is wrongly given. So A and B, so let's assume as same concentration is given as per the option, and C is 400 ml of 10% W by D. So concentration of C is very less. If concentration of C is very less, definitely the vapor pressure of C will be very high, and D is again the very high concentration. So definitely vapor pressure of D will be very again low. So very low here. So now correct order of this vapor pressure will be, so D is very low. So you can see PD is again B is we can see the low, but A, C, these options are wrong. In case of C, so vapor pressure of D is very low because concentration is very high, and PC is very low, so pressure is very high, and AB is equal pressure. So our option C is only matching. A, B and D are incorrect answer. So this C option is correct in this question. A sample of a volatile liquid is introduced to an evacuated container with a movable piston. So this volatile liquid is introduced, and what will happen when this liquid is introduced? This will convert to vapor, and which exchange occurs as the piston is raised, and what will happen? The piston is raised. Now what will happen? The fraction of the molecules in the gas phase increases, so of course it will increase. The pressure in the container will decrease. No, it will not decrease. Pressure will increase because the fraction of molecules is increasing. So P is correct answer. Q is not correct answer. Both P, no, this is the wrong answer. D is also wrong answer. So only P is our correct answer in this question. For a sample of liquid in a closed container, say a closed container, it contains a liquid, and which aspects of vaporization depends on the surface area of the liquid. Now the surface area of the liquids, we have 4 aspects. That is the rate of vaporization, which will affect. Next is vapor pressure. So which of the option is correct here? So again vaporization will depend upon the rate. Okay, it will not depend upon the vapor pressure. So it is independent of vapor pressure. This rate of vaporization always depend upon this vaporization, that is rate of vaporization. This aspect is only possible in case of closed container. So our answer is A again correct. Q, C and B, C and D is our wrong answer. Again P is correct like the previous cases. Our P is our rate of vaporization is our correct answer because it will depend upon the surface area of the liquid. The vapor pressure of water depends upon what? So vapor pressure does not depend upon the surface area, does not depend on the volume container, but it depends upon the temperature. Surface area of the containers, not surface area of the container is wrong answer. Surface area of the liquid is depending the rate of evaporation. Okay, so answer option 23 C is our correct answer in this case. A, B and D is wrong answer.